Math 266, Video 1, Integration by Substitution of Algebraic Functions. So in this first example, we're integrating x to the 5th times x to the 6 minus 20 to the 30th power. So how do we do that? Well, we're going to make a u substitution. We're going to let u equal x to the 6th minus 20. Then du will equal 6x to the 5th dx. Now if we go over here and we make our substitution, we'll see that we now have u to the 30th power, and what remains in terms of x is x to the 5th dx. So now going over here, we look and see that x to the 5th dx can be expressed as 1/6 du, dividing both sides by 6. So now we can make that substitution and replace the x to the 5th dx with 1/6 du. And now this is an integral we know how to solve. Applying the power rule backwards, we'll have 1/6 u to the 31st power. We multiply by the reciprocal of the new power, 1/31, and now we have our constant of integration. Finally, we do our last step, which is, we'll rewrite this as 1/186, and substitute back in for u, x to the 6th minus 20, and then we have our constant of integration. In the second example, we again have algebraic functions. We have x to the 4th times the square root of 17 plus x to the 5th. So to integrate this, we'll do a u substitution, and we'll let u equal 17 plus x to the 5th. Then du equals 5x to the 4th dx. So now if we go over here and make our substitution, we'll have the square root of u, and then what remains is x to the 4th dx, which we can express in terms of du by dividing both sides of this equation by 5. We'll have 1/5 du equals x to the 4th dx. So now we can make that substitution, and we're integrating 1/5 times the square root of u du, which we can think of as 1/5 times the integral of u to the 1/2 power du. And now we're ready to apply the power rule backwards. So we'll have 1/5, and as we integrate, we'll add 1 to the power and have 1/2 plus 1, or 3/2, and then we'll multiply by the reciprocal of that, so 1/3/2, plus our constant of integration. And now, if we clean up these constants a little bit, we'll have 2/15, and substituting back in for u, 17 plus x to the 5th to the 3/2 power, plus our constant of integration. In this third example, we're integrating a rational function, namely 1/9 minus 4x. So we can start with a u substitution, letting u equal 9 minus 4x. Then du will equal minus 4 dx. So if we go over here and make our substitution, we'll have 1/u, and then what remains is just dx. And dx can be expressed as minus 1/4 du, dividing both sides by -4. So we replace dx with minus 1/4 du. So now let's rewrite this a little bit with the minus 1/4 out front. We're integrating minus 1/4 1/u du. Now remember, when we integrate 1/x dx, it is the natural log of the absolute value of x plus your constant of integration. And the reason we have these absolute values here is because we don't know anything about the domain of x. So going back to our problem here, we'll have minus 1/4 times the natural log of the absolute value of u plus our constant of integration. And our last step will be to back substitute. So instead of u, we're going to write 9 minus 4x. In this fourth example, we're integrating another rational function, 1 over the quantity 2u plus 3 squared. And notice that the variable is already u, So we can't do a u substitution without getting confused, and instead we'll use the letter w. So we'll let w equal 2u plus 3, then dw will equal 2 du. So now going over here and making our substitution, we'll have 1 over w squared, and what's left is du, which equals 1/2 dw. So we replace the du with 1/2 dw. And now this is the same as integrating 1/2 times w to the minus 2 power, which is applying the power rule backwards. We'll add 1, that'll give us w to the negative 1 power, and multiply by the reciprocal of the new power, 1 over negative 1, plus our constant of integration. And finally, just rewriting this as negative 1/2 and back substituting, we'll have 2u plus 3 to the minus 1 power, plus our constant of integration. Or we could also write this as minus 1/2 times 1 over 2u plus 3, plus our constant of integration. Our fifth example is also algebraic, but it's got a little twist to it. So let's start by letting u equal x plus 9. Then du is just dx. So now if we start making our substitution, we'll see in the denominator here we have the square root of u, and what's remaining is x dx. But if we look over here, we'll see that we just have dx equal to du, so we can replace dx with du. But then what do we do about this x here? Well, if we look up here, we see that we can express x in terms of u by subtracting 9 from both sides of the equation, giving us u minus 9 equals x. So this will be u minus 9 over the square root of u du. Now to integrate this, we're going to distribute and divide the u and the minus 9 by the square root of u, giving us the integral of u over the square root of u, which is just the square root of u, minus 9 over the square root of u, du. And if we rewrite this in terms of powers, we'll be integrating u to the 1/2 power minus 9 times u to the minus 1/2 power. And now we're ready to apply the power rule backwards, so we'll have u to the 3/2 power Now we're ready to use the power rule backwards, so we'll have u to the 3/2 power and multiplying by the reciprocal of that new power. And then we'll have minus 9 times u to the 1/2 power, and we'll multiply by 2, plus our constant of integration. And then using our back substitution, we'll have 2/3 x plus 9 to the 3/2 power minus 18 times x plus 9 to the 1/2 power, plus our constant of integration.